When we get cold, the immune cells in our body fight against the virus or bacteria invaded into our body. In this video, I will simulate the battle between immune cells and virus using Python program and compare with the mathematical or theoretical model. First, the program generates immune cell and virus cells. The initial number of each cell is 50 and 50. This is the identity of the cell. This is immune cell and this is virus cell. And inside the brackets, this is the specification of target cell. That means immune cell attacks virus cells and vice versa. And if you add bacteria like this, the immune cell will boost the virus cells and bacteria cells. And if you look at the cell itself, the cell moves towards the one of the nearest target cells, and if the cell is close enough to the target cell, the cell will attack the target and eliminate the target cell. Let's run the program. The blue line is immune cell and the red one is virus cell. The immune cell is set to 4 times stronger than virus cells. So you can predict that immune cell will win the virus cell and virus cells will be eliminated. When the fight is over, the result of a simulation will be compared to theoretical function like this. You can see that it is well matched. I will explain why the theoretical function predict the real phenomenon using differential equation and Laplace transformation. One, the number of immune cells, and Y2, the number of virus cells and the rate of change of each cells are the rate of change of number of immune cells is negative K2 times the number of virus cells. K2 is the fatality of virus cells. That means how well the virus cells kill the immune cells per each second. And the other hand, the number of virus cells is negative K1 times the number of immune cells. Likewise, K1 is fatality of immune cells. This means immune cells number of immune cells decrease when there is more virus cells, and the higher the fatality of virus cells, the more immune cells dies, and vice versa. And how to solve this differential equation? I will use Laplace transformation to solve this. First, organize each equations. Right side becomes 0, and let us apply Laplace transform to each equation. And that becomes like this. And to solve this, multiply s to these terms and multiply k to this term, and we get y1 s. This is to get y1 in terms of time t, we need to apply reverse Laplace transformation. To apply that, we need to organize this term. It becomes like this. When you look at the Laplace transformation table, this becomes hyperbolic cosine, and this becomes hyperbolic sine function. So let us apply reverse Laplace transformation. y1 in terms of t is reverse Laplace transformation of capital Y in terms of s is this place. And result is this becomes hyperbolic cosine function. And this times this is square root k1 over k2, and this becomes hyperbolic sine function. Hyperbolic. And vice versa. The only difference between the two equations is the index replaced at each k and y, and the result is also just replacement of each index. And what's the meaning of this equation? Firstly, hyperbolic cosine is in this shape, and hyperbolic sine is in this shape. So we only handle when t is positive. So hyperbolic cosine is basically positive vector. That means when this coefficient is bigger, the number of immune cells tend to stay bigger, and this is the number of allies. This is common sense, because the more the number of allies, the more the number of cells itself, and this is the speed of phase speed. The bigger the value of this, the faster exhaustion of one of each cells, and this is here is minus 1, so this becomes hyperbolic sine becomes negative vector. That means when these two factor is bigger, the number of immune cells tend to become smaller. This is of course the number of enemy. And what is this? This is, we are handling y1. This is how fatality of number 2 is bigger than fatality of number 1. So this is relative weakness. So when the number of enemy is larger, the cells tend to decrease faster, and when the cell is weaker than the enemy, also the the number of cells tend to decrease, and this is likewise the speed of phase. So this is the solution for this equation.